Hello all. So now we are going to see a quick demo of my project for networks theory assignment 1. So it contains two files. One is manager, the other is peer. So manager keeps track of all the list of peers which are joining to the network. So whenever a peer joins to the network, it pings the manager and reports its listening port, which is kept track of in the active peers list, which is then broadcasted to all the active peers which are there in the network. And then the peer consists of so the main first function that is run in a peer is this handle manager. So what handle manager does is like whenever the peer connects to a network, it sends its IP address and port number, the listening port number, to the manager, which adds it to the active list, which and then it starts two threads. One is for updating the list of peers, and the other is for checking for any incoming requests from any other peers. And then until it hits the timeout limit, it will check for requests, and if any, and it will also send a request if it is supposed to be a request sending peer. So this is the code for the peer. And in this thread we are using some update peer list function, which just updates it according to what it receives from the manager, and check incoming request just creates a file request socket and keeps listening over it until it hits the timeout limit. So, and yet there are many other helper functions also, like read file into chunks, and which just takes in a chunk size and the file name as specified, and breaks it into multiple chunks and returns the list of chunks. And there is another function which sends the file request to all the peers present in the network. Then there is an initialize sender socket, which takes care of creating multiple sockets, so that the request sending peer can establish TCP connection with all those peers which have the file in the network. And then there is a get file chunks, which just creates multiple threads, spawns threads, and then receives those chunks from the peers which have the chunks, and then waits for them to send it, and then just appends it to one complete list, and then this is returned to a file which is named as received underscore the file name. So this is the receive chunks, and then there is send chunks, which just sends the chunks according to the index number. So here one thing to note is that like this whenever it is checking for requests, like whenever the file is checking for incoming request, it also receives a index number. So this index number is sent by the requester, which indicates which chunks it wants from that particular peer. So if the index number is 0, then it will receive all the even chunks from that, and if it is 1, then it will receive all the odd chunks in that fashion. So, and then finally when it receives the chunks, it will merge those chunks into the single file. After this, so yeah, let's see a demo of this code. So first we'll just demonstrate peer joining to the network, and how the manager is going to keep track of list and update the list, and then send it, broadcast it to all the peers in the network. So let's say we run this manager first. Now we add a peer to the network. So we see that it has sent its listening port, and it has received the peer list. Similarly, we can spawn other peers. So we see that they are getting they are like sending their details to the manager, and it is in turn sending them the list of all peers on the network. So all of them receive the current list of peers whenever a peer joins. And then this one has hit its timeout, so it has sent a quit message to the manager, which has updated the list of currently active peers, which is reduced to 2. And then after that, the second and the third peer is also left, so we see that they are leaving the network, and the list of active peers currently is 0, like it is empty basically. So now I'll demonstrate how a file can be sent over this peer-to-peer network. So for that we have to specify the -t, the type. T stands for type. So REQ means it is a request requesting peer, and it is requesting for the file hello dot txt. And then another thread that we are spawning here is a normal thread which just will respond to the request of this first peer. Now I'll just show you the hello.txt file. So this consists of just some random lines. So these are the first 6 lines, and then it is consisting of the bill of rights till around 38 lines. So this is the hello.txt, and once it receives the hello.txt, since the peer is spawned in the same folder, it will create a file called received underscore hello.txt, and it will contain the same contents as this. So let's do that. So I spawn this thread, so it has requested for the hello.txt. I spawn this thread, so it will say that it does have the so it will send the file request to this new peer which has joined, that is 8167, and it will receive the response as file is available, file found with this peer. Now I'll spawn another thread which will also respond saying that it has the file, so file available. And finally it will receive the chunks from index 0, index 1. Index basically refers to which peer is sending the chunks, so 0 and 1, and after it receives those chunks, it will close connection with the manager and it will quit. So and so will the others. So finally this all these peers have exited, and yeah, so this is the demo. And if we look at received underscore hello.txt, then there is a new file. There is this new file called received underscore hello.txt, which is having the same contents as the hello.txt file. So it was successfully sent over the network. So one thing to note here is that the network currently waits for two peers to join the two peers with the file to join the requesting peer will wait for at least 2 peers in the network to have that file, after which it will start accepting the files with even and odd. So that is one restriction that I need to correct here, but the requests are still accepted in parallel using these 2 threads that it is spawning, and then it is just waiting for those to complete. So yeah, so that is all for this demo, and hope you liked it. Thank you.